multi-networking pod stuff where you've got a pod and it might have two different sort of NICs attached to it, and all the rules, it's totally like all the rules change, all the rules for how you would normally think of, all the non-Newtonian physics of networking sort of come into play. Okay, so news, Antrea 1.4 is out. Thank you everybody for coming. Antrea 1.4 is out, and let's see, I see that it looks like there's a few people watching, so feel free to say hi in the comments and let us know where you're from. 1.4 has the most exciting news is it's got support for Antrea proxy, full replacement of kube proxy, complete total replacement of kube proxy, right? So it does everything, including affinity, including node ports, load balancers, whatever, external load balancers, cluster IPs, of course, that's been there for a while. And the real exciting thing is it supports Linux and Windows both, so that's cool. And I think it's by default now. Oh, it's disabled by default. So actually, you have to turn on proxy all in order to turn on all the proxying for all the endpoints. So in the sort of continuous trend of now you've got Cilium, you've got Calico, and now you've got Antrea, all these different CNIs now are actually doing service level networking for kube. Antrea, IPAM, okay, so a lot of you different CNI version CNI people are interested in things like, well, I want my namespaces to have a specific IP pool, and I want things like that. That kind of fine-grained stuff is kind of now flowing into Antrea. That's really important to enterprise customers who want tight control over IP spaces and things like that. Configurable transport interface insiders for pod traffic configuration for Antrea agent to choose an interface by network siders. I think this is important for Windows because, at least in Vagrant, it was important for some of our Windows testing of Antrea. I'm not sure if that's related, but you might have multiple NICs and multiple gateways and stuff like that. UDP support for node port local. That's a feature. Node port local is a feature that allows you to take like a, if you have a single pod and you have a node port local is like one of these, right? So you got a pod, and your pod, normally you'd expose it through a service, right? Normally you'd expose it through a node port, right? Normally you'd expose this pod through a node port, and then you've got your clients over here that access that node port, and then that node port service forwards you to the pod. And of course, if you do this, then it's sort of, you have to do this on every node of your cluster, right? So you would have another, except for that there's an external traffic policy local in Kubernetes that allows you to not do this, but that allows you to do like local traffic. But normally when you do a node port, right, like I could get load balance to here, or I could get load balance to another pod here, right? And so node port local is like an Antrea feature that allows you to sort of expose a pod IP to the outside world through OVS directly, without having to create any kind of an intermediate service. And I guess there's reasons for that when it comes down to like wanting a more fine-grained definition of how you access a pod endpoint without having to make a global node port service.
Could you just humor me and like, what's the use case for that? Like, who wanted that?
I think it's because the external traffic policy local or stuff is sort of complicated and doesn't work in all use cases. Like there's certain types of load balancer scenarios where it doesn't do exactly what some people want it to do. There's a proposal, I can look it up because I remember there's a lot of back and forth on it.
Yeah, this should also tie in with how you use your traffic policy, right? For example, if you're just going to do node port and you're going to have traffic policy as local, of course you cannot have the pod in another host, because once you put cluster traffic policy as local, your kube proxy IP tables are programmed only to forward to the pod in the same host, right?
Yeah.
So, and if you're going to do cluster IP, you're going to have extra hops. These are all some things that we face in the telco world where they want to avoid the extra hops. Even if you're using cluster, say you use node port, you send your traffic to one of your worker nodes, but the pod is in, say, host 2.
Yeah.
You use your host 1, and then you're going to reroute it again to host 2, which is an extra hop. So, whereas if you do node port local, you're going to directly expose it using a node port in the host where the pod is running. So you can try to potentially avoid an extra hop as long as you route it to the correct host.
Yeah,
that's pretty interesting. I wonder how it differs from host port.
So yeah, there was some debate about this, right? So there's external traffic policies. Some people say external traffic policy local does kind of address this, right? But there are scenarios I remember because there was a proposal floating around where they said it didn't. So external traffic policy local does, and host port too, right? Like I guess both of those. But in either one of those scenarios, I guess so if you external traffic policy local, it will reject, I think, a connection unless the pod is local. So you could build a load balancer that's like smart there.
Yeah, and that's where what Vivek said makes sense, right? So even with external traffic policy set to local, when traffic hits a node, it would still need to translate into a pod IP through cluster IP translation. That's one extra hop on the telco world, which is too much delay. But host port just exposes the pod directly on the node. So I wonder how host port is different from the
But what if you have two pods which needs to be exposed on the same node? How does host port work? It should be similar to node port, I guess, because you need unique ports, right?
Right. Yeah, host port is just exposing a port on the host for a particular pod.
I want to say hi to everybody. Ipirva is here from, he's over from Vmware. Doug Smith, hey Doug, what's up? I saw you on Twitter earlier. Scott Rosenberg, it's our friend, very, very, very great partner of ours. And he's testing Windows on Kubernetes, so he's a very, very special person to me. Prentice Fry, what's up? How you doing? Okay, from Texas. I'm from Oklahoma, man. Okay, and Andy Pierce from London and Antonio from Italy. Cool. Well, this is great. I feel like we're starting to build a little bit of a community up here. It's the most people we've ever had on a show this early. So I really appreciate you all coming. And if you want to send me your emails, maybe we can send out some T-shirts, some Antrea T-shirts. So anyways, let's go on. So host port, I don't know. This is an interesting thing. So if anybody from the Antrea, any of the engineers are around, like, why is it different than host port? Go on, Arun. I interrupted you.
No, that was the exact same question I was thinking about. How is it different from host port? Might be a little more to it. Maybe something around moving pods between hosts and then keeping the open flow rules in place so that pod movement can happen more easily. Because host port is still specific to a particular host. So might be something in that sense, but yeah, I'm just taking a wild guess there, so I don't know.
So maybe what happens with node port local is it sort of gives you the best of both worlds. Who knows? Okay. Like maybe it works in certain scenarios where host port doesn't work. I don't know. Okay. Well, I don't think host port works in Windows. Maybe that's part of it. So yeah, I don't think you could do a host port on Containerd in Windows. And so if you use Antrea for your CNI in Windows and you do the node port local, it means you can have the exact same behavior on both. You can use the exact same thing to do that behavior. Right, Luther? I'm right about that, right? Containerd host ports, you're not going to get a host port out of that because there's no Docker bridge. Right?
No, so the problem I was saying is, right, when you have, say, two pods for the same service running the same host, somebody has to take the pain to go and make sure that the host port they are populating in their definition are unique. I don't think two pods can share the same host port, if I'm not wrong. Whereas in node port, you don't really go and configure the port, right? This is something that you get from that ephemeral range that you have between 29,000 and 32,000. It's automatically handled by the queue proxy. So yeah, that's one difference. Because if you have multiple pods of same service running in the node, then you run into this issue.
Yeah, so this
host port is really good when you have only single instance, right? And then if you want to expose that, then you can try to use a particular port.
Yeah. So I'm going to go on Antrea Slack, and once this meeting starts, and I'm going to see if we can get any of the Antrea engineers, because Jiunjin wasn't able to make it today, to join us and give us a little tip on this. Now, let's jump to node port local.enable configuration parameter for Antrea. Okay, so we've already talked about it. We've beaten that dead horse. Antrea proxy skips services configuration parameter to the Antrea agent to specify services which should be ignored by Antrea proxy. Okay. All right, so that's similar to, they have that in kubeproxy, right? They have a similar thing where you can annotate a kubeproxy service to skip proxying certain endpoints. So I guess you need to do the same thing for Antrea proxy. Add support for 2 services, which rule Antrea native policies allow matching traffic intended for services. Okay, so we're starting to get, that's Grayson. And Grayson couldn't make it today because he got sick. And you know who else got sick was Yash. So we got a lot of there's a lot of drama in the Antrea community right now. But we missed you today, Grayson, but we can commemorate you with this great PR that I guess you did to sort of give us these service levels.
I guess I see how I ended up on this stream, huh?
Yeah. It's just we're just scraping from the bottom of the barrel here.
Oh, good. I know when I get the call up, it's because something hit the fan.
So, add user. That's not true. Luther's my friend. I like Luther.
It's all
okay.
good.
Add user documentation for WireGuard encryption and NCAP mode for EKS. So we've got some cloud native stuff that's going into Antrea. Let's focus. Some of you that use other CNIs like Calic or whatever probably have thought a little bit about this whole NCAP versus non-NCAP thing. So I guess Antrea acts as a primary CNI of the EKS cluster. Major benefit is here. So I guess maybe it's smart enough to use NCAP when it needs to, or maybe something like that. Okay, Antrea is the primary CNI. Pods are connected by the overlay network, and pod IPs are allocated from private CIDRs configured for an EKS cluster, so the number of pods per node is no longer limited by nodes. Arun, can you tell me what this means? You're an Amazon guy.
You spoke too soon, Jay, and I haven't played with Antrea as much, so let's see. Let's read it slowly. When Antrea is a primary CNI, pods are connected to Antrea overlay network, and pod IPs are associated from the private CIDRs configured for an EKS cluster. And so the number of pods per node is no longer limited by the number of secondary IPs per instance. So when you use Amazon VPC as a CNI, right? So the Amazon's CNI IPAM, there is a limit to the number of, so each pod interface that you create, it creates a elastic IP of sorts that is associated with an instance. Okay. And then that's how the Amazon CNI with VPC works. So I'm guessing there's a limit to that, and going this way allows you to ride over that limit.
Okay, NCAP. Okay, because so it's just okay, but it slows things. Does that make things slower? Is there a performance hit here?
No idea.
Now that you're in NCAP, I assume every time people say NCAP, they always say that it's harder or slower. I don't know. Okay, well that's it. So I think that's all this stuff for 1.4. But again, I think the big headliner for me is the complete decoupling from kubeproxy.
Hey, if somebody knows, can somebody talk about the new IPAM feature that has come in Antrea?
Let's see if there's anybody here in the audience that is from, let's see, Scott says, VPC CNI limits pod per node to really no numbers. Yeah, okay. And that makes sense. I just was, I'm wondering what the hit you take from the, but yeah. I don't know if we have any Antrea engineers with us today. Might just be me. And I'm not an Antrea engineer.
Okay.
So I'm assuming it does the same thing that the other CNI IPMs do, right? Let's take a look. So if I have this IP pool here, I could literally define an IP pool, and then all the pods and namespaces that are annotated with that IP pool will come up within this range of 10.2.0.12 and 10.0.2.20 or whatever, right? So, and I think you should be able to either do this with pods or namespaces. I'm pretty sure. I mean, I'm just kind of making that up, but yeah. So if you annotate at the namespace level, it means all the pods in that namespace will come up that way. But I'm assuming you can also add that annotation to a pod. And the only reason I I know this is because we had a customer that wanted to do this the other day. Yeah, where is the docs for this? So let's see if we can look here. So if I go here and I go to my favorite thing in the world, grep.app, and I look and I see what where these annotations. A pod's IP will be allocated. Oh, that's the change log. We're already there. Okay, so we need IPAM annotation key. So if we look in here and we look through the code, can we find where, let's see, and then let's go in the unit test and see. So, okay, so namespace, namespace, namespace. Maybe it's only for namespaces because I don't see it for pods. So I guess at this point, and I can't, don't quote me on this, but if I look at the unit tests, all the unit tests that are using this feature seem to be annotating the namespace of the pod with the IPAM key. So I guess the question here that I'm going to have is whether or not, can I just leave it? Let's see if there's an issue for it, right? So IPAM pod annotation. 3 closed. What happened? Okay, so the original feature was centralized IPAM based on namespace. Antrea relies on host local IPAM based on Calico. Yeah, because you could do this in Calico. It's pretty common, right? And in Oven, I guess you do that too. I propose an IPAM method based on namespace isolation. Okay, so the entire feature is based on namespaces. You've got a namespace, you've got a pool for the namespace, you annotate the namespace.
Got it.
Luther, can you do that in Flannel? Can you do IP pools?
Why would you ask me the hard question?
I don't. So Luther's a Flannel maintainer. So if any of y'all have Flannel questions, feel free to ask Luther. Let's see what Scott has to say here. Scott, it's changes based on instance type as well, so it's not always easy to calculate, and you end up wasting resources with VPC CNI. Okay, cool. Yeah, back to the Antrea stuff. Yeah, the EKS stuff. Cool. All right, so I think we're ready to get into today's topic, which is like super exciting, which is Multus and whereabouts and host local IPAM and all this weird stuff that only telco people know about. But we have 2 people that are like sort of telco-y. Well, one person that's really telco, Vivek, and Arun both, right? I don't know. I think Arun, are you doing telco stuff all the time now too?
No, don't count me into telco.
I can't call you telco? Okay.
No.
I think everybody that knows more about networking than me, I just call them a telco person. All right. Vivek, take it away. Show us everything that you know about this whole whereabouts stuff.
Sure. I think there is also Doug in the participants. I think he's the one who is the main contributor for whereabouts. So a big shout out to him too.
Oh, Doug, I didn't know. Okay, Doug, you're a whereabouts. Okay, you work on whereabouts. Cool. Well, Doug, if you're an upstream Kube and you want to join the stream, just let me know. Send me a DM and I'll add you to the stream. We'd love to have you to talk us through some stuff. Hi, Susan. Susan is my friend. She helped me set up this show. She runs all the Antrea stuff, like all the like sort of media and all that stuff. And so thanks, Susan. Good to see you here. Okay, cool. Arun, I think we lost you, but that's okay. So let's see here. And Susan says anytime. Okay.
Just some Apple issues, guys. Just give me a minute. I'm trying to share my screen, and of course it doesn't allow. So just give me a minute.
Okay, cool. Zoran. Zudong! Me and Zudong are on the same team. Zudong is... I'm sorry, no, that's Lubron. I thought it said Ziar. Oh, okay, it's Lubron, yeah. Me and... Wait, yeah, this is Lubron. Okay. Your name is Ziaron, but it says Lubron. Okay, cool. That's the English, I guess, pronunciation. Cool. So, me and Lubron are actually also on the same team. So, me and Lubron work on TKG networking together, and he's here with us today. That's great. So while Vivek is showing up, does anybody have anything they want to talk about or ask us about? I think Luther is still looking up IP pools in Flannel.
Yeah, no, that IP pool thing, I'm going to get you an answer by the end of this.
You know, we can look at, because it's kind of interesting, is there was an issue I remember Kubernetes services with kube proxy, no routing. There's like an annotation. It's probably useful for people to know. There's a rule that you can. There's an annotation you can put on services where you have the service not proxied by the kube proxy. But I forgot what the annotation is. But I learned about it the other day, and I was kind of surprised to see it.
Is that a feature in antrea proxy?
I mean, it seems like it's the opposite of a feature, but it's like
It kind of does, doesn't it?
It's like disable kube proxy for a service. Fangyan, who I used to work with, replaced kube. Yeah, no, that's not it. Kube proxy replacement. Vivek is rejoining here.
Yeah, I need to restart my Chrome. Just give me a second.
No problem. Yeah.
So Zach Y asked if you can increase your resolution. It's too small.
What's up, Zach? How you doing?
Do you know everyone? Is everyone on here your friend?
I pretty much. Well, not Prentice from Texas and Andy. All the new people, Susan and Lubron.
Yeah, those are my folks. They are from the telco world. So.
Oh, okay. So everybody's either
People.
Vivek got us some.
No, I didn't call them. They joined with themselves. So.
They joined. Yeah, okay. So they're organic. It's organic growth.
Okay. Organic growth, indeed.
So, there's an annotation that you could put on Kubernetes services that allows them to that's checked, and then if you turn that on, then a service won't get plumbed through the proxy. And I think but I don't remember what it is anymore. We can just look in the source code, right? So we can just go to the source code. So if I open up VS Code, right, we can just look. Okay, that's the wrong code base. Source Kubernetes. So if we go into the proxy, let's see. Annotation. Well, there's the whole topology thing, which is a different thing, and then there's yeah, maybe we could see it if we look in Proxier. Skipping it, can't open port, can't find it. I know how I can find it. There's an issue, and it was opened up by, you know who opened it? Fangyan opened it. I remember the issue, and I know his GitHub ID, so I can look it up in there. Author. Yeah. Service proxy label, yeah. This one. Yeah, so if you do service proxy name, if you do this one, right, then I think that's it. Yeah, service proxy name, right? So if you do service proxy name, then you can skip proxying. You can disable, yeah. Yeah, here it is, in service.go. Yeah, service proxy name. There it is. Service proxy name. So should implement service.service proxy name. So we create services, and when you create it with that label, it's disabled, right? So it's a little trick for disabling kube proxy for certain services. So you can still create a service, but it'll be disabled, and then you can use a different proxy to service that, to proxy those requests on your node. So yeah, Vivek, how you doing? You ready?
Okay, good. Let me try to share now.
Okay, cool. I'll add that to the show notes. If folks want to help me with the show notes or add questions to the show notes, I'll put the link in the... Susan says, hi, Lubron. I'll put the link in the show notes here, so you can join us here this hackmd file, and you can add notes or add questions in here. So let me add this service proxy. Yeah, where was it? What was it? It was, what was the name of that label? It was service proxy name, right? Yeah. Service proxy name. Annotation on K services that disables proxy. Okay. Vivek, I see you. Okay, Multus, let's go. All right, cool. Arun. You got booted out of the studio? That's weird. I don't know how that happened. It's interesting.
Okay, you guys. Okay, I can see the screen myself. Okay, so before we go into the multi-screen, right, I just wanted to touch base on the CNI for folks who don't know what it is. This is the specification which is used for handling the network interface component of all your containers. And they have really defined certain CNI operations here, which will be used during the different life cycle of your pod to attach network interfaces into your containers or pods. So what I would like to really go about and see now is probably about the need for these secondary interfaces in telco, right? So hopefully I just put up a 3-slide thing. So first thing is like, why do we need Multus in telco use cases? One is, this is what I was explaining last week, that there is a need for supporting multiple networks in most of the telco accounts. They would ideally like to separate their, say, management and traffic network, or they would like to separate even at a finer, more fine-grained level, that they have separate one for signaling, separate one for those NS which are running in data plane, and they want to carry the data plane traffic in a separate network. So there's really a use case where the telco operators want to support multiple networks which are ideally isolated from each other, right? And then second thing is, as I was saying, we were trying to avoid as many hops as possible. And as you know, when we use the CNI interface, for example, based on the way you place your pods and the way you configure your service, there might be multiple hops which your packet takes. For example, it can land in one host, and then if you put it as cluster IP, and if the pod is in another host, you may have to do one more jump hop to go to the pod, which we would like to bypass as possible. And of course, this is also the main way by which interfaces based on SRIOV or DPDK or EDP, something which is VMware specific. So these kind of interfaces, if you want to present inside your pods for, say, higher network performance, you leverage Multus to present those secondary interfaces inside pods. So these are some of the potential use cases. And how do we present multiple interfaces inside pod? Mainly we use Multus, and some more Multus. So it's mainly Multus, right? And of course, Multus CNI also provides you with a lot of.
So can you tell us what SRIOV is, or do you have a picture of it, that like a diagram or anything somewhere we can look at for folks? Because Junjin said that the Antrea folks, he left us some notes here, and he mentioned that I don't know where the notes are, that he mentioned that Intel and the Antrea folks are working on some SRIOV related integrations, and he set a PR for it, but I didn't really know how to describe what SRIOV is.
Yeah, I'm just trying to see if there's an easier thing that I can show you, which is sort of at a higher level. So let me try to see. I'm just grabbing some picture from the internet. So
yeah.
So if you see here, an SRIOV is a way by which you have a physical interface on your host, and when you're running VMs or pods in your VMs, this is the way by which you present those interfaces directly inside your virtual machine at if you see here, you have your virtual NICs, and these are directly presented inside your virtual machine with direct memory access, DMAs and all that stuff, so that the applications running in your VMs can directly access those VMs in the user space, and they can handle the networking operation there, the input-output operation there. So this is a way by which, especially as a SRIOV, is a way by which you have one physical, they call it as virtual NICs or VFs, and you present these VFs directly inside the virtual function. So whenever a packet is sent, it doesn't again go through the host kernel. It will directly go from the virtual machine to the physical port and to go out.
Does the VM request a virtual NIC from the physical NIC? Is that how that works?
Right. So there is a mapping that is done when you enable SRIOV, and when you bring up a VM, you can say, hey, I want to use this virtual function. And there are some Intel-related drivers which are present in your VM, which helps bind this virtual functions in your VMs with the physical function in your host.
I see. So when you're making a kernel request to do anything to the NIC in the VM, he's just bypassing it straight down to the physical NIC. Well, the virtual NIC on the physical NIC. Correct. So you have to have an SRIOV enabled NIC. Come by. Where do you even get those? What's the How do
mostly it's supported by? It's an Intel term, right? So there are most of the if you see here, there are specific NICs from Intel which support. There's a specific family of Intel NICs which support this technology. It's becoming a bit more widespread now. Okay. But yeah, there is.
But one could say that this is a specific, sort of a specific NIC designed for hypervisors. Is that a good way to say it? Because it's a hypervisor specific kind of thing, right? Like this, I don't see why anybody would need this except for a hypervisor server, right? It's something.
Telcos.
Is that a first? Well, telco, the same thing. Well, you said how many VMs over here?
That's the answer to every networking. Why would you need this question?
Yeah, that's a good point. Actually, it's valid.
So generally, this will be used. Of course, he told telco, but anything where they want to avoid unnecessary high latency, where you want to again go through the host's kernel, right? Because you're directly bypassing it now. So anywhere where you need a higher network performance, like reduced latency or something, you will generally go for this.
So I'm probably not getting this on my T3 micros, is what you're saying. That joke did not go over well? Okay.
Well, according to Doug, it's something that, it's like...
a unique brand of fun, yeah.
It's for people with fancy computers.
It sounds like it.
Yeah. All right. Okay, sorry, keep going.
So, so that is one, but there are also other technologies that you can use. Rather than SRIOV, you can also sort of use MAC Vlan or IP Vlan, right? You still have one interface, but then you attach an interface to your VM, and then you can use MAC Vlan or IP Vlan based interfaces to present secondary interfaces inside your pod, right? And this is also used by multiple telco customers because each interface inside your pod is ideally connected to different networks that we were talking about in the earlier slide. One for signaling, one for OAM, one for actual data traffic. So they will have multiple pods inside. So, of course, Multus provides an ability to add multiple interfaces into your pod, and based on the CNI spec, it's just a chaining, right? So when you create a pod, you create your network attachment definition. This is basically the way by which you attach secondary interfaces inside your pod. This is a CRD, which is provided by Multus. And then again, you can add multiple secondary interfaces if you need inside a pod. So let me show that. Let me open up the CRD for Multus.
Scott, you got any war stories about SRIOV? I'm just kind of like, that's kind of an ominous.
There has to be something there, right?
What is he? There's got to be something there, right? Okay. I don't know what happened to Rune. I don't know what happened. It won't let you rejoin. But who knows? Doug might join us because I just sent him a link on K8 Slack.
So what Multus provides is a CRD, which is called as network attachment definition, and you define your secondary network's characteristics there, and then when you annotate your pod with the name that you give here for the CRD, Multus will make sure that it is also in the chain, in the CNI chaining, and then it will add that secondary interface. And then, of course, you can call multiple plugins on top of that, like your IPAM or your meta plugins like VRF and stuff. And then Multus will help us program that secondary interface inside your pod. Of course, we will take a shortcut network attachment definition as such with a live example if needed.
Should we on the left side put up the standard plugin.json for folks that may not know the?
Yeah, I will touch base on that, right? So
okay, you'll go there later. Okay, keep going.
Yeah. So I was just trying to touch base on what is a network attachment definition and how you use it. So let's try to look at an example. For example, let me quickly show you guys. Oops, my lab is timed out.
Doug's here.
Okay.
How you doing, Doug?
I'm doing great. Thanks for having me on. I appreciate it. Vivek, I don't mean to slow your roll, but yeah, happy to pitch in where I can.
Sure. That should be helpful. Yeah. So whenever I talk about wearables, I'll definitely lean on you, Doug. So yeah, as we were saying, we use network attachment definitions to attach secondary interfaces inside the pod, and Whereabouts leverages that thing, right? For example, if you're using Whereabouts, this is a typical example that they give where you create a network attachment definition. This is just a name for you, which you have to annotate your pod with. It conforms to the CNI version 030. And then here is where you say what is the type of interface you're adding, and the types which are supported are in the cni.dev page. If you go to the plugins, you will see them here. So you have a support for IP VLAN, Mac VLAN, TTP, host device. So you have a variety of them.
Type always references a binary that's stored in like /opt/bin, right? Like
Correct.
Type is weird because it's called type, but really it's like path, or it's like.
So they use that name to execute the binary there. Yes.
Yeah.
So they have different types. I'll probably be touching base on these two today, the IP VLAN and the Mac VLAN plugins. If possible, probably I'll just touch with Mac VLAN, and then if needed, we can go into IP VLAN. And then, sorry, let me go back here. And Whereabouts is all about this section, where when you want to program your interface with IPs and say some network characteristics like routes that you want to program inside your pod, which wants to leverage the secondary interface, that's where this IPAM section comes in, and Whereabouts is one of those. So the whole, Doug, you can correct me if I'm wrong. The whole reason why they came about with Whereabouts is based on certain limitations that we have on the IPAM supported by the CNI community as such. As you can see here, we basically have 3 IPAMs which are supported out of the box from the CNI, which are DHCP, host local, and static. Each one has their own scope. For example, if you say static, it's really like there is just a single IP or something that you configure there as IPs, and then this section, this IPAM section you see here, go here, right? This is the section, for example, if you're using static instead of Whereabouts.
Yeah, you nailed it. And a quick backstory, just to add a little bit of color, is the original inspiration for Whereabouts is from the Multus Quick Start Guide. We have an example that's that uses a host local IP, and basically people would use it. They're like, hey, this is great. And then they would go to use it on 2 nodes, and they would get a duplicate IP on the second node because host local only has allocation per node. And I'm like, geez, it seems like more and more people have this kind of requirement that they don't want to use DHCP for whatever reason. Maybe you don't have it on that isolated network that you're creating as a secondary network. But you want to dynamically allocate from a pool. So that was kind of the initial inspiration, and it actually started as a fork of the static plugin and just built on that. But yeah, that IPAM section, that's like a whole like spec from the CNI maintainers themselves. So it's easy to just build yet another CNI plugin that's executed like other CNI plugins. And the CNI API just says, hey, this is the stuff you pass back and forth.
Right. So he's talking about this, right? Okay, this is the configuration, but I can go to the spec here. They explain it here. This is the one. So each plugin, when it is called, it has to give the output in this particular format. So just to add to Doug's thing, right? So if you see these three, the DHCP, the host local, and static, if you see the scope, the static IP is just for a single pod, right? So if you are going to use static IP, you're going to create one network attachment definition per pod that you want to use secondary interfaces for, right? And you have to use it. So, and if you take host local, as Doug was mentioning, this is really at a single node level. So you create like an IP pool, which you can use for IP allocation within that particular Kubernetes node. You cannot share this with another node, because then you're going to end up having pods with duplicate IPs on different nodes for the secondary interfaces. And whereabouts is something which is at a cluster-wide level, I would say. So for each cluster, you go and create a NAD, right? And then once you create it and you run, let your whereabouts run. Any pod which wants to use, want to get an IP for the secondary interface, if they refer to this network attachment definition, whereabouts make sure that each pod gets a unique IP. So if you see, the scope progressively becomes higher, right? It goes from a single pod to a node to probably a Kubernetes cluster as such. And then again, if you take it even further, stuff like DHCP can be at a network level, right? You define DHCP, and then you can run your DHCP server centrally in your network, and then you can probably handle multiple clusters using the same network, as long as the DHCP server is able to service all of your network segments. So if you see, it just goes progressively higher the way you can use these IPAM services, right? But of course, each one has their own limitation, or I should say, kind of a drawback when you consider how they're going to use this in production. Say, where I'm going back again to the telco world, where we have hundreds and thousands of cell site nodes, which needs to leverage this, because most of the network function providers in the 5G, especially the containerized world in RAN side, they are using or leveraging secondary interfaces to.
What's the cell site node? Oh, is that literally like a thing that?
So this is more like cell site is where you have your actual radio tower, I would say, just to give an easy comparison. And they have containerized the software which is running there, and they have made it to run on top of Kubernetes, right? So now when you run your software, they want to, leverage secondary interfaces, because the network requirements at a radio site is very high. They really cannot take any latency, right? The latency requirements are so strict that it has to be in order of milliseconds, single-digit milliseconds. So they really cannot use the primary network interface and have extra hops, which can potentially include extra delay, right? So they want to directly bypass all that and use secondary interface and start using it. So if you see that, and when you come back to this IPAM, the problem we have is, if you use the static way, for each software instance that is going to be run on these sites, you need to create one network attachment definition. And if you're going to talk about 1,000 nodes, somebody has to go and create 1,000 of this network attachment definition, make sure that they are created with the correct IPs in the correct nodes, and then they have to go and program it.
Okay, I see. So where you're going is that none of these things are flexible enough for what you want to do in the telco world.
Yeah, especially when you take it to production, right? It's all good for POC, right? Proof of concepts is good when you have limited number of nodes. But when you talk about the scale that we are talking about, when you want to take it to thousands of nodes, we have a problem. Okay. So if you take host local, again, this is at a node level, but again, this will have the same limitation that when you take it to thousands of nodes, you need to configure them. And if you go to whereabouts, it's a bit better where you define it at a cluster. So if a cluster, say if you have 1,000 nodes, you're defining it using, say, so it depends again on different infra vendors. Some of them support one Kubernetes cluster per node. So even if you use whereabouts there, somebody has to go and configure this on each of your Kubernetes cluster, which is per WAN site. This is similar to.
So I would have a primary CNI like Antrea, and then I've got Multus running, and then I've got Whereabouts also running as a secondary CNI, and then Whereabouts.
So Whereabouts is more an IPAM, right? It's more for the IPAM part. The secondary interface itself is handled by Multus with probably one of these plugins, right?
Okay, all right.
But where Whereabouts help is in the IPAM part.
Okay, so I'm sorry. Okay, so I have Multus, and then what I use is I just have Whereabouts as a replacement for the IPAM plugin.
Correct. So by default, if you had seen, mostly people use host local. I think Andrea used to use this in the earlier release, where you define IP pools per node, and then you leverage the host local functionality to provide IPs. And if you take Calico has their, I'm not trying to compare, but Calico has their own IPAM, which they use for providing IP, right? So it's mostly about the IP address management for those secondary interfaces. So the CNI spec as such is agnostic as to what you are.
This is a good day then. So it's like we're announcing 1.4 that has Antrea IPAM support, and then you're also showing us how you can have a secondary CNI that uses a different IPAM for your telco network, and so you can do that.
You can possibly put Antrea IPAM. That's the reason why I was asking. But I wanted to see what are the capabilities it supports. As of now, it seems it's namespace, but probably we can extend it to provide something like what.
Next time we get Whereabouts, maybe we can do a show with that. Yeah, that's cool. That would be cool.
Yeah, and then of course, Whereabouts is again per cluster. Whereas if you say DHCP is one potential solution where you have a centralized DHCP server which can handle your addressing needs. So this is possibly something that you can take out to your field, right, when you deploy it. This is something that is of interest to us. But yeah, the decreasing order of preference is DHCP, Whereabouts, and host local and static in that order, in my opinion.
And I think we've only got about 10 or 15 minutes left at the most. So is there anything you wanted to dig into that's going to take a while? Because if so, we may want to jump.
Sure. Just give me a minute. I'll try to explain the limitations, right?
Okay, cool.
The main problem we have is, of course, in telco, the nature, how they handle it is, they are not really, even though they are leveraging the Kubernetes solution as such, the way they deploy and manage the life cycle of software which is running in the cell site or anywhere is not going to be where it's really ephemeral. They deploy a network function, and it's going to stay there for some time, especially when you're using secondary interfaces. Your whole concept of Kubernetes service goes away, right? Because there's no Kubernetes service which is going to map to your secondary interface. There's no programming which occurs at the kubeproxy level. So the problem we have is these functions are going to be there for longer time. And say we have multiple networks, and say customer wants to extend the network with an extra CIDR, right? He's adding an extra subnet into that particular network. As of now, there is no way we can, and if you see here, there is a way you can program routes into your pod secondary interfaces. Some of the plugins support it, some don't, right? This is again one of the capabilities which is needed. So that's one thing that we need to check in Antrea if it supports. If it's not supported, this may not be really usable, because these are the ones by which you effectively say, hey, if you want to reach possibly these network subnets, you use this interface, right? So you use this for programming some routes to make sure which interface you use to go out. Okay. The problem we have is if future you want to add another entry here, for example, say 192.169.0.0. As of now, even the CNI spec doesn't give us the ability to add anything once a pod has already been instantiated. If you see the spec, if I go back here, you only have these, and these are only called during either a pod's creation or deletion. There's nothing that is available right now to update this network characteristics during a pod's life. So the only thing they have to do is
there's some work in progress as part of the network plumbing working group that creates Multus. That's a discussion ongoing about hot plugging and unplugging interfaces. There's at least one fork of Multus out there called Cactus that has done this for quite a while. It's based on sort of an old version, but yeah, if you check out the Multus repo, there's even recent pull request related to it, but keep your eyes on the horizon for it. And the way that it winds up working is, so CNI plugins they're kind of like typically a one-shot process. Like the binary kicks off, it does its job, and it exits. And we refer to that as a thin plugin, and that's the way that Multus works, and like all the reference CNI plugins that you mentioned, like Mac VLAN, IP VLAN, Bridge, all that stuff. The way that this will work is that it'll be a quote-unquote thick plugin, which basically has two parts. One part that we call a shim, that's basically the one-shot CNI plugin process, and then a thick component that's a resident daemon that runs in memory that's a Kubernetes controller, and it'll watch those annotations so that you could theoretically plug in and unplug during a pod lifecycle. So there's another discussion that's ongoing too about CNI version 2.0, and I'm curious what we'll find out out from the CNI maintainers, what winds up in there. But I have a feeling that like during the lifetime operations will probably be a consideration.
And to answer your question, so thanks, Doug. That's okay. That's interesting. So this 2.0 stuff, is it still being planned?
Yeah. So Casey Calandrello, who's one of the maintainers and the originators of CNI, he gave a talk about it at Virtual
KubeCon Europe 2021. He gave a talk. Yeah.
Yeah. So he's been going about the community to socialize it and see what people have to say. But I'm pretty sure that once the new year rolls around, we'll start to see a lot more from the CNI maintainers on it. But
did he also mention that like we might go gRPC for CNI at some point?
So that's definitely been a discussion. I'm not exactly sure what's going to go on there, but it sounds kind of exciting to me. And the idea that you're naturally going to have that kind of long-running process type of communication with gRPC, right? So right now, if we didn't mention it, CNI plugins, they just speak via standard in and standard out. So that's the API over which they talk. So the improvement that's possible would be gRPC for CNI. So yeah, I think that would be awesome. I hope that's the way it goes.
Yeah, you could get heartbeats and all sorts of weird stuff if you did that.
Yeah.
I'm assuming for now. Okay. And as far as Apirva goes, I think it's probably a good question. I assume people taint nodes, or they add tolerations and taints, and they just use the scheduler for that, the same way they do for other hardware. But I don't know. His question was, how do you schedule an SRIOV enabled node?
Oh, and you know what? So SROV, there's a SROV device plugin, and what device plugins do is they talk to the Kubernetes scheduler and gives the scheduler awareness of what resource has been utilized. So that way, as like part of the process before a workload gets scheduled, the scheduler knows if there's...
The scheduler directly targets SRIOV-enabled nodes based on not only whether they enable SRIOV, but they can quantify whether or not they actually have any SRIOV.
Yeah, so at runtime, no problem. You may find that you have to, depending on what you're doing, you might need some like pre-set up on your nodes beforehand to like get all the drivers and kernel args and all that stuff, right? But once it's all set up during runtime, should be fairly seamless with the device plugin.
I had no idea.
Let me pin the site for the SRIOV DP. So commands. Yeah, so let me just take one more minute to finish, right? We have seen that in telco, well, at least, not all IPAM plugins support IPv6, where some of the telco operators are trying to go into IPv6, and so we are again limited by the IPAMs we can use. For example, the DHCP plugin, which is upstream, doesn't support IPv6. So ideally now it's either whereabouts or host local or static.
Yeah, we can't see your screen right now though, so you need to re-add.
Oh, okay, you removed it.
Yeah.
Okay, so that
I
is
didn't
one.
remove it. I don't know what's going on. StreamYard's being weird. Yeah.
Okay, and then the third thing is there is no IPAM now which has something like a IP withhold timer, which you used to have in DHCP, right? Nobody has implemented something like that now, where say a pod is running on a node and for some reason it has been booted out and been rescheduled in another node. As of now, none of the IPAM plugins support providing the same IP again to the pod, if I'm not wrong.
Oh, persisting the same one. What about?
Yeah, so if it is a pod as such, and if the pod name doesn't change, probably whereabouts can do it. But if you're really going the deployment way, the pod name is going to change, and then you end up into an issue where you're going to get a new IP.
Oh, okay. So they don't support things like stateful sets?
Stateful set. So it depends, right? It depends on the network function vendor. Some of them use deployments. Some people use stateful set, but majority of them, at least what we have seen, use deployments. So we have this potential issue too. Where
because if I have a stateful set and I delete the pod, it's going to come back and it has to have the same IP by definition.
Not for the. We're not talking about the primary, right? We're talking about the secondary when we leverage one of.
I suppose the secondary just are totally different. Yeah, like all the rules get thrown out the window, right? They probably don't support stateful sets the same way. They probably don't support network policies the same way. Probably all sorts of stuff breaks down once you go into a secondary CNI.
Yeah, definitely.
Like, do services even work on a secondary CNI? Like what?
No, that's what I was saying, right? Services, there is an hack. You have to automatically populate it. There is an kubeproxy doesn't do it for your secondary interfaces.
Yeah.
Because it doesn't even know it, right? You can see it in the pod's status field, if I'm not wrong, but other than that, it doesn't get reflected in the endpoint. So there is no way your service can work on creating any plumbing for your secondary interface IPs. And also the whole point or objective is to bypass your the CNI networking whole stuff that you're doing using IP tables, right? You want to directly go out via the secondary interfaces. So we haven't seen a use case where somebody's asking like, we'll have secondary interface, but we want to use the kubeproxy way of reaching it. I don't think anybody has asked us stuff like that as of now.
Some of that functionality, the network plumbing working group that specifies the stuff Multus is built on is looking into too. So one thing for sure was one of the original goals with Multus was to have it just be an absolute sidecar to Kubernetes, that you didn't need to modify core Kubernetes, you just use C9, you've got an extra interface, there you go. However, as you mentioned, yeah, some of the Kubernetes-like functionality that you might expect isn't there. So network policy and services being right up there. There's, as part of the GitHub org, the Kate's Network Plumbing Working Group, you'll find a network policy extensible application that currently works for Mac Vlan for sure, but could be extended to other
so the network plumbing group has like a template of how you would actually implement policy.
Yeah, if you go to the go to the root group and then look at the repos, and yeah, there should be a network policy. If you filter it by policy, you should find it. We have a number of
y'all are busy over here.
Yeah, we got some
27
stuff.
repos for one working group. I've never seen that in my entire life before.
Oh man, that was
Damn.
we're like, this is a doers group, not a talkers group. We
You,
do
you
some
don't stare
talking
at
too.
Google Docs the whole time and just like talk
Yeah.
about stuff?
Hey, don't worry, we're a working group, so we do a fair amount of that too. But yeah, that's one thing. There's also a lot of traction on some work with services for secondary networks.
Here we go.
As well.
So you have a network policy controller that uses IP tables to enforce certain network policies based on the device. That's cool. I wish Ricardo was here right now because I was telling him this is what we should do for. I've been wanting this forever. I didn't know this existed.
Cool, yeah. Give it a try, and big credit to Tomofumi Hayashi, who really spearheaded this effort. He did an awesome job, and I know that he would love to get some more traction and usage to get feedback on it. I mean, we're really happy with the stability, but like the more
there's a
churn it gets.
Policy. This is so cool. I had no idea this existed.
Sweet.
Did you know about this, Vivek?
A little bit. I keep tabs of what they are doing. Of course, I don't have time to try out all of this stuff, but yeah, I do keep tabs on what they're doing.
Ricardo, if you're here, look at this net.
Yeah, I think I am pretty much done with at least the overview that I wanted to give and try to explain the use cases for the secondary interfaces and the limitations we are facing, right?
Yeah. Well, I mean, I hope you'll come back again and we can do some like hacking around on like a on an Antrea plus Multus environment. That would be cool.
Yeah, I do have it. Unfortunately, we didn't have time to go through it, so
that's fine.
You can call me anytime and I can come back and we can do a live session where we try to use whereabouts and Multus to assign IPs to secondary using pods, right? Yeah.
Well, and Doug, if you ever want to come on the show and hang out with us or show us anything you've been hacking on or anything, you know, you're always welcome. Just like reach out or whatever, or anybody really. You know, like anybody in the audience. If there's something you want to talk about, we're a new group here, so it's like, you know, it's like there's no rules, you know. So okay, we do this every Wednesday, and yeah, it's. Even though it's technically the Antrea live stream, it's you know, hopefully more of a community event than anything else. So let's hang out again. And so Vivek, thanks again. Like, you've helped me out on a few of these, and I appreciate you always being willing to jump in on stuff. And Doug, thanks for coming at the last minute. And Arun and Luther, I don't know what happened to y'all, but thanks for coming. I hope Arun's okay. I don't know what happened. This computer crash or something. And we will see y'all, I guess. Anything else y'all wanted to talk about before we drop? I see like new people are joining, but the stream's kind of almost over. I feel kind of bad.
No, I'm good.
Okay, cool. Well, thanks everybody for coming today, and watch this show over again. There's a lot of stuff that Vivek went over and Doug that you can learn about. So thanks. Doug, you're over from Red Hat, right?
Yeah, that's right. Yep, I'm at Red Hat.
All right. Do you work with Antonio?
Yeah, Antonio is awesome. Yeah, we used to be on the same team. I think he's moved over a team that's like more Kate's API focused. But
stuff now,
yeah, he's a beast.
He's unstoppable.
Yeah, totally. Jay, I have a feeling you probably work with Andrew Stoikos. He's on my team.
Yeah, I know Andrew.
Good dude too. Yeah, awesome.
Yeah, definitely. Yeah, we love Andrew. Andrew's taken over the network policy group, and they're really close to having cluster network policies. So we're excited about that.
Sweet, that's awesome. Yeah, I knew that you were super involved at the beginning there, at least. So yeah, that's cool. Good work, guys.
Yeah, definitely. Let's keep in touch, and maybe you and Andrew come and do a show with us sometime.
That sounds awesome. Yeah, thanks for having me again. And yeah, great show. Thank you.
All right, see y'all. Bye, everybody. Project Antrea Live. See ya.